Hi again. We're going to keep going with the lithosphere. Moving on to the energy resources that we can extract from this sphere of the Earth. So we're starting with fossil fuels. A question for you. How many liters of gas are consumed in Canada in 1 year? Now might be a good time to pause the video if you want to discuss and take a few guesses before I give you the answer. So, how many liters of gas are consumed in Canada in 1 year? 40 billion liters. 40 billion liters. That is a lot of gas. All right, let's keep going. So here are the kinds of questions that you're asking yourself today. What resources are contained in the lithosphere? So what resources can we find in the lithosphere? How are fossil fuels formed? And what are the effects of fossil fuel use? Your lesson objective is I can judge the impacts of energy extraction and use. This one will come up for pretty much every sphere we discuss. We want to make sure that you can tell us what the advantages and disadvantages are of using certain forms of energy. And you'll see what that means hopefully by the end of the lesson. So, the lithosphere contains more than just minerals. There are lots of energy resources in it. Humans extract oil, natural gas, and coal in large quantities. With these resources, we heat buildings, we power factories, and we fuel our vehicles. So all of that driving that we do is coming from the lithosphere. Fossil fuels. Fossil fuels result from the transformation of organic residue. So that's going to be dead plants and animals, basically. So fossil fuels, there's three kinds: oil, natural gas, and coal. The energy that comes from these fossil fuels is called fossil energy. We see some over here. So, petroleum and natural gas formation. The ocean, 300 to 400 million years ago, we have all these plants and animals. They died. They got buried on the ocean floor. Over time, they get covered in sand and silt. So here we see them. Plant and animal remains, sand and silt. And they get buried deeper and deeper and deeper. This results in a lot of heat and pressure because they're being squished down constantly. That eventually turns them into oil and gas. And then today we drill down through layers of all this sand, silt, and rock to reach the oil and gas deposits that are buried deep down under there. When marine animals die, like we just said, they go to the bottom of the ocean. Then they are covered by sand, silt, and other rocks and minerals. Over a very long time, the pressure from the layers above them turn them into oil. This is how oil and natural gas are formed, both by plants and animals in an ocean. So I'd like you to sketch the formation of oil and natural gas in the blank space in your notes. So I'll show you this again. You might want to pause the video, take a few minutes to make sure that you have this kind of thing in your notes. If you're not an artist, that's okay. But it is just a different way to try to help you remember it, so I encourage you to give drawing it out a try. If If you haven't paused the video and you still need more time, you might want to pause it now because I'm about to keep going. All right, let's talk about how coal was formed. Coal is formed really similarly to oil and natural gas, but it formed in a swamp, so it forms on land. Okay, so here's a swamp 300 million years ago. You have all these big plants and this kind of stuff. So before the dinosaurs, a lot of giant plants died in those swamps. Then you have all these dead plants. They get covered by dirt over a long period of time, millions and millions of years. They get buried under water and dirt. Again, all that pressure takes those dead plants, squishes them down, and turns them into coal. And then today we dig down and we mine coal usually, actually. So we'll dig a mine down here and haul coal up to the surface. So coal comes from terrestrial plants and trees that once grew in swamps. So the difference is it doesn't get formed in an ocean. Over time, they get buried under sand and silt. This pressure turns the organic residue into coal. Coal is a solid, unlike oil, which is a liquid, and natural gas, which we know is a gas. So I'd also like you to include the formation of coal in the blank space in your notes. Here they are again. Please pause the video because for the sake of the video size, I am going to keep going. So pause if you need time to get this down. All right. So burning fossil fuels emits thermal energy. So the word thermal might sound familiar. That's heat energy. Thermal energy can be converted, so we can change that heat into electrical or mechanical energy, and this is the kind of stuff that we do to make an engine run. So combustion also gives off byproducts. So this burning of fossil fuels is combustion, and one of the things that it produces is carbon dioxide, which the chemical name for is CO2. So CO2 is the principal greenhouse gas behind climate change, meaning that it is the major cause of climate change, CO2. Combustion also produces sulfur dioxide, which is SO2, and nitrogen oxides, which we call NOx. Those are responsible for acid rain. And natural gas is mostly composed of methane, so CH4, and this greenhouse gas actually is 20 times more powerful than CO2, so using natural gas is actually worse than using oil like we use in our cars. So, by the end of today, I'm asking, can you name the resources contained in the lithosphere? We talked about 3 different things that we pull out of the lithosphere for energy, so you should be able to name all 3. Can you explain how those fossil fuels are formed? And can you describe the effects of fossil fuel use? What is happening with all of this combustion? What are we talking about a lot of the time? Your teacher has the answers for these questions, but you should be able to give them to him first. So, that's the end of today's lesson, and I will see, well, I won't see, but you'll hear me all again next time.